Grenton Academy, Part 3, Grenton Modules. Good morning, my name is Marek Pollitt and I invite you to our third training video where you will find out what modules we have in our offer and what functionalities they offer. From the previous video, you already know the structure of the Grenton system. Remember that the CLU module supports up to 48 modules. And if you need to have more than 48 modules in a given system, you add another CLU, and thus you can expand such a system with another 48 modules. You connect the CLUs to each other using network infrastructure, while one CLU module supports a serial bus, TF bus, whose total length should not exceed 300 meters. For each CLU, it can have two catches, and at the ends of the bus, you install terminating resistors. If you remember well, the loop cannot be branched or further looped. The Grenton system is a truly hybrid system. What does it mean? First of all, we use both types of communication, both reliable, fast and stable wired communication using the TF bus, as well as light and universal wireless communication using Z-Wave technology. What's more, the system works both as a centralized and a distributed solution, with the use of the greatest advantages of both technologies. But how does this work in practice? Here you have an example of a typical system, a CLU module, several modules mounted in the switchboard, several distributed modules mounted in a flush-mounted boxes, and 3 touch panels. In a situation where the CLU module and the whole system is working properly, all communication in the system is done using the CLU module, i.e., if you want the button in the touch panel to turn on the lamp, then this communication will be as follows. First, the information that the button has been pressed will be sent to the CLU module. Then the CLU module will send the information to the module to which the lamp is connected in order to enable the output with the lamp. However, in the situation where the CLU module for some reason stops working, is cut off from the bus or is damaged, i.e. it is simply not present in the system, communication will be simplified directly between the control modules. i.e. if you press the button on the touch panel, then the order will go directly to the module, which will know that it should turn on the lamp in this case. It will look exactly the same in the case of communication between other modules. If the input to which the switch is connected is switched on a given module, the command will be sent directly from the module which the switch should control. Grenton offers 3 types of modules. We have modules for installation in a DIN switchboard, we have wired modules for installation in flush-mounted boxes, and we have wireless modules. Let's get to each of these types of modules in turn. The main module in the Grenton system is the CLU module. It is a module that is responsible for storing configuration, for communication between modules, and for communication between the mobile application and the system. Each CLU module has a built-in bus controller and supports up to 48 devices connected to this bus. The CLU model also has an internal converter that allows the bus to be supplied with a maximum of 1 amp. The function of the CLU module is primarily to store system configuration and make calculations, but CLU also allows for remote access to the system using a local network, applications from smartphones or tablets, as well as communication using the Grenton cloud. It is enough that the CLU module is connected to a router with internet access so that you can have remote access to the system. The next module in our offer is the relay output module. We have 3 versions of relay output modules. The first are modules for installation in a switchboard for mounting on a DIN rail. The second version is a wired module for installation in a flush-mounted box. And the next version is also flush-mounted, but for wireless communication. Modules for installation in a switchboard, i.e. those modules on a DIN rail, depending on the version, have 4 or 2 relays in a normally open system with a maximum load of 6 amps per channel. Each of the channels is separated from the others, i.e. can be independently controlled and provided with input values independently. So for example, in a 4-input model, a 230 volt load can be connected to input 1, a DC load to input 2, for example 12 volt DC, and to input 3 simply connect a contact system, and each of them can be controlled in this way. In addition, both the rail mounting models and a real energy measurement system that allows you to measure the energy consumed by the load connected to each of the outputs separately, and a system for detecting passage through zero. This system is designed to switch on the load and switch on the output when the sine wave is close to zero. Another relay module, the module in the flush-mounted but wired version, is equipped with 2 relays with a maximum load of 1.5 amps, also in a normally open system. A load with a maximum power of 350 VA can be connected to both channels. This module also has a zero detection system and an actual energy measurement system, while in this case the energy measurement will apply to both channels simultaneously. So, in the case of a module mounted in the switchboard, each of the channels had its own independent energy measurement, while in the case of a flush-mounted module, there will be a common measurement of both channels. The module in the wireless version has 2 contacts with a load of 8 amps. And I haven't told you one thing yet. In the case of a flush-mounted wired module, this module is equipped with 2 outputs, i.e. 2 1.5 amp relays, but additionally with 2 inputs to, for example, a lighting switch, and 1 wire bus controller can be connected, or 2 Ds, 8 in and 20 sensors. The last relay module in our offer is a wireless module. This module also has 2 relay outputs with a load capacity of 8 amps each. It does not have an energy measuring system, and there is no system that allows it to be switched on closest to zero sine wave. What do we use the relay output module for? The relay output module is a very universal module that will allow you to control on and off basically any receiver that you connect it to. It can be used to control lighting, i.e. if you want to control the lamp on an on-off basis, you can use one of the module's outputs for such a purpose, and also connect LED lighting, both 230 and 12 volt. But it is also possible to connect kettles, stoves, recuperation, fans, throttles, garage gates, entrance grates, alarm systems to such a device, i.e. virtually any appliance that will be controlled by switching contacts on and off. Another module that we have in our offer is the Grenton I/O module. The module has 8 relay outputs and 8 potential free outputs. To potential free outputs you apply contact signals, i.e. logical 1 will appear in the system when a short circuit occurs between the GND contact and one of the outputs. In the case of relay outputs, we have 8 relays with a load capacity of 1.5 amp each, while in contrast to the relay module in which each relay has its input and output, here we have 1 output for 4 relays. So if we give, for example, 230 volt voltage to the output for a given group, it will be fed to all 4 relays from the given group. This must be remembered especially when using this module to control the receivers by shorting the contacts. Of course, if you want to control that receiver in this way, you have to remember that you cannot give more voltage there. What can we use this module for? The spectrum of this use is very simple as in the case of the relay module, but we must remember that we have relays here that are much smaller than those used in the module Relay 4 or Relay 2 HP. But we can also use this module too if we talk about outputs to control lighting, ventilation, recuperation, all kinds of valves for heating, and any other receivers on an on-off basis, in exactly the same way as it was in the case of relay output modules. But when it comes to outputs in this module, we can use them primarily for connecting traditional lighting switches, for connecting all kinds of sensors, for example motion sensors, opening sensors, i.e. contractions, wind sensors, or information from limit sensors. The next module in our offer is the dimmer module. This is the module used for dimmable lighting. At the moment, our offer includes a module for installation in a switchboard, i.e. on a DIN rail. The flush-mounted module version is currently in the design phase. The switchgear module has one output with a maximum load of 250 VA and a control system based on MOSFET transistors. This module is used for dimming lighting that is adapted to it, i.e. traditional incandescent bulbs or incandescent lighting, halogen lighting, and LED lighting, the kind of lighting which is dimmable. What is very important for this module that you can configure it to work mainly with LED lighting. You can change the control method, i.e. choose whether to control the rising or falling slope, and you can shift the start, especially in the case of LED bulbs, dimming of which sometimes starts not from 0 but, for example, from 10%. You can set a minimum here in such a way that it starts immediately from the 10%, and also the maximum can be adjusted so that, for example, it controls up to 90%, because some LED bulbs in the higher range are simply no longer able to properly brighten, i.e. reach the maximum value definitely earlier. The next module in our offer is the digital in module. It is a digital input module that has both potential free and voltage inputs. Here we have 6 potential free inputs that recognize a short to ground, i.e. that logic 1 in the system will appear when we short circuit the signal between the given input and the GND contact, and 3 230 volt outputs, which means that in logic 1 it will appear when a phase potential appears at a given input. The inputs can be used, for example, to control a traditional switch using a phase switch, but we can also use it to monitor whether there is simply voltage on a given circuit. What can such a module be used for? First of all, for connecting traditional lighting switches, i.e. similar to the I088 module, but also for connecting any type of sensors with contact output. i.e. it can be a contact, a motion sensor, it can be a rain or wind sensor, switch terminal connected to the entrance or garage gate. These can be light sensors, smoke detectors with contact output, and many other systems. But if you also wanted to monitor the status of the alarm system using such a module, system information can also be connected to it. Then you will know if the system is armed or unarmed. The RGBW LED module is a module used to control LED lighting, constant current, i.e. for a voltage of 12 and 24 volts, the same as with the dimmer module. At the moment the module is available for installation in a switchboard, i.e. for a DIN rail. The flush-mounted version is currently in the design phase. The module supports LED strips with the option of changing the colour in RGBW technology, i.e. with an additional white channel at both 12 and 24 volts. You should remember that the module is not a power supply, so in order to properly connect or control the LED strip, you will need an external power supply which is connected to the module, and then the LED strip, which is also connected to this module. The maximum module load is 16 amps per channel or 20 amps for the entire module. Why 16 amps per channel and 20 amps per module? Because the module can also be used as a 4-channel dimmer. If you would like to connect to each channel separately a single color LED strip and control it separately, or simply connect one channel or one LED strip, then you have up to 16 amps. If you would like to connect 2, 3 or 4 strips, you have a restriction here up to 20 amps per module. The next module in our offer is the roller shutter module. The roller shutter module is available in 3 versions. In a DIN rail mounting version with a maximum load of 3600 VA, a module for installation in a flush mounted box with a load capacity of 350 VA, and a wireless one with a load capacity of 1800 VA. In the case of a wired flush mounting module, you can also connect 2 inputs to it, as was the case with the Relay I/O module, i.e. there are 2 inputs here. Controlling one roller blind, you can also connect here temperature sensor DS18B20 in an amount of 2 pieces. The roller blind module is used to control roller blinds, electric curtain rods or awnings, i.e. those elements that are equipped with a voltage controlled motor. This module is also used to control facade blinds, which can control both slats and blinds on an open-close principle, and only one module for this type of drive is usually used. So one module will be used to control the slats on a close-open principle, as well as to control the entire roller blind, on a lift-close principle. There is no need to use 2 control modules. Analog in-out module, i.e. a module to which signals from analog sensors are connected. This module has 2 0.5 volt inputs with increased sensitivity, 4 0.10 volt inputs, 4 0.10 volt outputs, and 1 wire in the number of 2 circuits, i.e. you can connect 2 buses to it. What do we use such a module for? As for the outputs, any sensor with a 0.10 volt output can be connected to them. There are really a lot of these sensors on the market, and you will definitely find a temperature, humidity, wind, carbon dioxide sensor, light sensors, and many more. This is a popular standard used in industrial automation. The 0.10 volt outputs are mainly used to control lighting. You will find on the market a lot of power supplies controlled by 0.10 volt signal, but also if you need to connect to the system of valve with smooth operating control, then you also use the outputs for this type of purpose. Another example of use, some ventilation units allow integration with the use of 0.10 volt signal as well as air conditioning systems. Very often in the case of duct heaters, the fan speed is controlled by 0.10 volt signal. As for the 1 wire bus, you can connect 2 bus threads and a total of 16 DS18B20 temperature sensors to this model. Grenton also offers a number of integration gates. The first is the Gateway Modbus gateway. This gate works in a master mode, i.e. you can connect any devices working on the Modbus bus, but configured in the slave mode, you can connect up to 16 receivers to one gate, i.e. if you want to connect more than one device to the system, you do not have to use as many gates as you have Modbus devices, but you can connect everything into one Modbus bus. Up to 16 devices can work simultaneously on one bus, and these devices can work at different bus speeds. In the case of the Gate Modbus module, at the configuration stage, the speed at which the device to be communicated with works should be determined. Another very important issue in the case of Gate Modbus module, there is a full configuration of supported registers, i.e. at the configuration stage, you are able to integrate it with virtually any device that will be connected with it. What is such a gate used for? First of all, for integration with HVAC devices, for example, air conditioning, ventilation, recuperation, and various types of boilers, heat pumps, but very often it is also used to integrate with ready weather stations that offer this communication standard. The next gate in our offer is the Gate Alarm Gate. The gate is used for full integration with alarm systems. At present, we support 2 alarm systems. This is the alarm system of the SATL Central Control Panel from the Integra series and the Jablotron company, using the JA121 communication interface. The RS485 communication is used here. As part of this gate, we can download information on the status of the control panel zones and outputs to the system, and information on the status of partitions, while we can also control or arm or disarm a given zone. The last gate in our offer is the Gate HTTP gate. It is a gateway that we use to integrate with devices or service using HTTP protocols. The gateway supports HTML protocols, JSON protocols. You can construct text queries or using the POST-GET structure. The gateway is mainly used for integration with multimedia devices such as audio equipment. You can, for example, connect Sonos company speakers or Yamaha or RTI music equipment to the system and integrate it with your system. But also connect smart TV, any stations or weather service. Using this gateway, you can also download information from the internet to the system or send information from the system to other servers to the other side. The next element of the system is the bus module. The bus module is not involved in the system configuration. It is used to facilitate work in the electrical switchboard, to facilitate the transition from the main strip layer to the layer of the electric wire. In this module, next to the bus connectors, there are connectors to which wires from the bus cable are directly connected. This module is also used to connect additional power to the system bus. Grenton also offers a family of touch panels that can be used to control all elements in the system. Of course, we are talking here about our stylish touch panels. Let's start with the basic model, i.e. touch panel 4B. This has 4 configurable and programmable buttons, and for each of these buttons up to 4 independent events can be configured. It also has an additional built-in light and temperature sensor. What's worth paying attention to is the way of installing touch panels. You do not need any special or dedicated boxes to install these panels. They can be assembled directly on an ordinary electrical box. A simple mounting ring is screwed onto such a box with 2 screws, and then you put and screw up the panel. Thanks to this, assembly can be done very quickly and in a simple way. Another panel that we offer is the 8B touch panel. This is a larger version of the basic panel. There are 8 fully configurable and programmable buttons and, like the 4-button module, a built-in light and temperature sensor. Both the 4B and 8B touch panel can be used to control every element connected to the system. It can be either lighting, blinds, or any other device connected. The touch panels can also be used to run scenes or situation scenarios. The last control element that we offer is the Grenton Smart Panel OLED. This is a touch panel equipped with 4 freely configurable buttons and a small LED display. In addition, this panel also has a gesture sensor, and what is more about this panel, the content that is displayed is fully configurable, and the optical gesture sensor in addition to the fact that it can be used to directly control system components, i.e. for opening, closing roller blinds with gestures and turning on and off lighting. It can also be used to change cards or pages on this touch panel. The panel, which has 4 standard buttons, can be configured in such a way that on the first page the lighting in a given room will be controlled. After waving a hand in front of the panel, the page is changed to the second one, where you will have your favourite scenarios. On the third page, you will have a thermostat to control the temperature in the room where you are, and thermostats from the whole house or from the apartment. On the third page, you will have a thermostat to control the temperature in the room where you are, and thermostats from the whole house or apartment you want to control the temperature in, which can be programmed there. The display can additionally display any system messages. These can be alarm alerts, alarm on system failures or messages that will be downloaded from the internet. For example, information from stock exchanges, information about the weather, or current exchange rates can be displayed. Thank you for your attention, and I invite you to the next training videos where you will learn how to properly power up the Grenton system, how to prepare the configuration, and how to create your own interface controlling the mobile application. See you.